Limits of rational function. We saw polynomial function. We are looking at rational function. A function f is said to be a rational function if f of x can be written as g of x by h of x. Here g of x and h of x are polynomials such that h of x is not equal to 0. Okay. Then if I apply limit to such a function as x tends to a, I can apply the limit to individual expressions, that is the numerator. We can do this separately, and then we can apply the same thing to denominator as well. And this is how we will solve such a question. But sometimes when we apply the limit, either the numerator being 0, it's not an issue, denominator will be 0, and also the numerator is 0, and sometimes it is not. So there are different cases. Let me explain this. If h of a, the denominator, if it's equal to 0, when we substitute obviously a, since it's a polynomial function, we'll substitute a directly. If the denominator is 0 while the numerator is not 0, then the limit does not exist for that particular expression. For example, say I have limit x tends to 4. In the denominator it's x minus 4. In the numerator, say it is x plus x square plus 10, something like this. So we know that we can apply the limit to both the numerator and denominator separately. X square plus 10, and for the denominator we have x to the power of, sorry, not x to the power of x minus 4 as x tends to 4. So we just learned that this is a polynomial function, so I can apply the limit directly. So this is 4 square plus 10, and this is 4 minus 4. So clearly what do we have? We have some number in the numerator, right? So this is 1626 divided by 0. Such a scenario, we don't have the limit which will exist. Okay, so there's no solution for this. Now there is one more particular case. Actually there are two more cases, to be honest, but we just studied this. What we have here is both the numerator and denominator have 0. Results in 0 when we substitute a. In this case, limit does exist, and we can get the solution by factorization. How can we factorize and all of that? That is your normal splitting the middle term, or there are so many methods. This one more additional condition: for a degree in the numerator should be greater than the denominator. Again, if the degree in the numerator, if it's lesser than denominator, then the result is the limit does not exist. So all of this condition put together, we have the limit existing. Example, this is a result that you guys will study about actually. Limit x to the power of 4 minus 5 to the power of 4 divided by x minus 5 as x tends to 5. So if we apply the limit directly, what happens? Since all of this is polynomial, we will get 0 by 0. Now since we are getting 0 by 0, means what? There are common factors. See, what does it mean? This implies the numerator and denominator have common factors, common factor or factors. So we can simplify to an extent wherein the denominator will get cancelled, or some aspect of denominator will get cancelled, which is resulting in it being a 0. Okay, so let me do this. X to the power of 4 minus 5 to the power of 4. I'm not going to do a lot of math over here. I'm directly writing the answer. All of this is something that you guys are familiar with. So this can be written as x square plus 5 square and x plus 5 into x minus 5. So this is a simple 9th grade or 8th grade syllabus. and then we have in the denominator x minus 5. So this and this gets cancelled, and we just have the following expression: limit x tends to 5. So we can apply it individually to individual expression, and we have the following result. So we have this to be 5 square plus 5 square, that's 2 times of 5 square, and this is 5 plus 5. So this is basically 2550 into 10, that is 500. Okay, so this is how we can solve such a question. Right, see, end of it, if both the numerator and denominator having it tending towards 0, if it's resulting in 0 on substitution of the given value, means what? They have a common factor. So factorize it. Once we factorize it, they will get cancelled. And after that, it is a matter of simplification. Okay. By chance, if we get a scenario wherein the denominator has a lot more expression than the numerator, and post simplification, if you have things which is leading to 0 in the denominator, we can't do anything. Okay, so that case you won't get. So this is just a general knowledge. It's a commonsensical thing. So I just wanted you guys to understand that. So all of this will be used in your exercises. So you guys need to understand and think over and do write it.